Hi, my name is Magnus. I work for MoneyFarm, and I'm going to talk about the value classes. Okay, so I'm going to talk about value classes. Value classes are a language feature of Scala that's been around for quite a while. It's a fairly basic one, but it helps you to better model your data, or can be. It's very easy to overlook value classes. I found when I was learning Scala, I was sort of skipped over value classes, and it wasn't until much later that I realized I was actually solving a problem that I was really having. So before we start going into what value classes are, I'd like to just briefly go over the actual problem that it's solving. So if you imagine if you have somewhere in your code have an order like this, it has a product and a customer and a quantity. Because this is going to be stored in a database somewhere, they're all the product IDs are integers because it's going to be a foreign key to a database somewhere. And this will work fine, and this is quite a common pattern. But you can easily end up with code like this, where if you notice that the customer ID gets assigned to a product ID and the product ID gets assigned to a customer ID, and because they're all ints, the compiler is quite happy with this. So this can easily end up into the production. And even you can have code like this, where you have a collection of orders and then you're filtering by some criteria that's nonsensical. And even worse, that you can have a test like this, because you're just writing a test, you don't really care about what the actual values of the identifiers are. And then you can have a test like this that passes even though there's at least 2 bugs in the code. So what do we want to do? So really we want to not have integers as product IDs or customer IDs, because they are not integers, they are identifiers. So Scala has this one language feature, which is the type aliases. And it just allows you to alias the integer to a different type. So you can create another type, say product ID, and then it's assigned to an integer. And it will then get compiled down to an integer, and it will have no performance overhead. It will just work as it would. And of course, if you have this code and now you have a product ID and a customer ID, and if you run this compiler, well, it still compiles because the type alias gets compiled down to an integer before the type checker gets a chance to verify that this is not what you want to do. And in fact, this test still passes even though you have even though you have gotten rid of the ints from your order case class. And that is where value classes come in. So value classes is like type aliases. It gets compiled down to the underlying type. So it has an underlying type here. In this case, is an int. But the way it looks like is you have a class that has to extend any val, and has to have exactly one underlying field, and has to be a val. So in the case of a case class, val, all fields are val by default. But if you're using just a regular class, you have to be aware that you can't have a var product ID. It has to be a val. And the order looks the same. Now it has a product ID, and now they are case classes instead of type aliases. And now when we try to run this through the compiler, what we'll get is a compiler error. And that's really what we want. We've now managed to use the type system in Scala to make this particular bug just not representable. You can't have this bug because it will just refuse to compile. But if you look at this example, slightly different. We're comparing two values, and we don't get the compiler here. In this case, we get the compiler warning because the equality is just Java's object.equals, which works on object, or which in Scala is any. And you can compare an any to an any, so this will pass, but it will always produce false. So at least at least you have that. At least it'd be more difficult to have a test that passes in this case. But we can even make this to a compiler error, which is having fatal warnings as a compiler option. Just generally a useful feature as well, and that will make the previous warning as an error. And this is also why Scala set and cats have their own definition of equality, because we avoid this problem operating on any's, because you can have nonsensical code like this. And that is value classes in a nutshell. Has to extend any val, has to be one, the underlying field of the class has to be a val, and it can't be another value class. It doesn't recurse. And then it just compiles down to the underlying type, and it compiles down before the type checker, no, after the type checker has had the chance to check that actual code is typed correctly, and that's it.